Hello everybody. I put together a presentation to troubleshoot a Hool C-Model ignition circuit. It's a pretty common circuit and has a lot of components involved in it, so I'd like to walk through the steps that I would usually take when troubleshooting this particular circuit on the vehicle. All the coaches that the circuit applies to are mostly multiplex Kibbe's 32 systems. And some of the components we look at, you'll be able to tell it's Kibbe's 32 system just by looking at the modules that are there. So quickly looking over the steps for troubleshooting this circuit. The first step is always to locate the correct wiring diagram. In our case for the Hool, we would use the portal from Hool to look up the vehicle by VIN range to get the correct wiring diagram for that VIN. Then we would find the page for the ignition circuit to troubleshoot the circuit that we're looking at. We also need to identify the diagram components, which I'll discuss for everybody's benefit, and then beginning of the diagram explains all the components. So before each page of the diagram we're going to work on, it's going to explain what the components are, which we'll also cover. And then we want to identify the conditions, what needs to see 24 volts or what needs to see 0 volts to make the system work. Luckily in this circuit, everything will be 24 volts. And then we're going to check the circuit as identified in the test points in order to isolate where the problem lies. So we're going to start here. This is the first page of the wiring diagram, just to point out some important facts of the diagram. There's the model that we're working on of the vehicle. It's going to have the year of this particular diagram. Some of the diagrams may cover multiple years, but in this case, it's 2018. You also have the wiring diagram number, and then you have the Hool VIN range if there's one that is applicable to this wiring diagram. Some have a VIN range in here, some do not. Alright, so once we have our wiring diagram and we found the page, in our case for the starting circuit, here shows the entire starting circuit and the ignition circuit for the bus. We're going to focus on the center section here because this is what's required just to make the whole vehicle just turn on and get ready to start. So this would be the first place we would start if we're having issues getting the whole vehicle to power on, and before we can even get to the point of pushing the start button and starting anything. So zooming in on this page, I'm going to cover a couple of these items quickly, and then we'll go on to where you can find the descriptions of all these components, what they actually look like as well. So the page, almost all the pages start with power supply coming from the top of the page for the diagrams. In this particular case, it shows B+. That just indicates that this following circuit gets powered from the battery directly. It doesn't go through a master relay, or it's not an ignition source or anything. It's always powered. So when you check for this circuit breaker, Z081.2, in the circuit, we're always going to see 24 volts there, as long as there's 24 volt batteries hooked up. There's also two switches here on the page, SO68 and SO80. They're actually one switch all put together. That's why there's this little box around all of it. So they're individual switches, but they do two different functions, and it'll describe what those functions are on the following page. So you also have relays. This is a regular automotive style relay. A single slash across the center of the relay just means that it's a low current relay, like a 20 amp relay, 15-20 amp relay. We also have the node number 3 in this particular case, so we have to make sure we understand where that's located at and how that works. And then you have the pinouts on the nodes, D2 in this case, A13 it looks like, and E2. You have the DMUX, which is the center dashboard computer, which we'll discuss a little more detail. You have SO77, which is the push button switch. You can see here it's a momentary push button switch to do the starting of the engine. There's diodes. These individual diodes, they're individual because they have no pin numbers on either side of them. That's how we know they're individual diodes, and they're easy enough to locate on the vehicle once you know what you're looking for. And then we have the diode blocks, which says DB1 instead of just D. That stands for diode block, which means there's multiple diodes in a single relay base sized component. There's a accessory component here, which is just a bridge. That's what the BR stands for, and all this does is just turns on a certain feature that all vehicles have when they're building them, and they remove this bridge before delivery. This just shuts the vehicle off faster if they're out sitting in the yard and somebody forgot to turn the master switch off. So then you also have these indications where the circuit goes off the page or comes from another wiring circuit. So 36B on the top right, that's the page for the exterior lights. So the flasher input comes in on that circuit if necessary. And then 05A1 XX1 is circuit XX1 on page 05A1, and that goes on to some of the components to turn on the main 24 volt relay. So all the other conditions before that have to be satisfied before we would even focus energy on that part of the circuit. We also have two more diodes that are part of a diode block 1. So in fact, all three of these diodes, these two here on the right and the one on the left, they're all part of the same diode block. They're just individual pins. And you can see the pinouts listed on either side of the diode. And we have the ZR, which is the main computer that has the program in it that operates the whole coach. And there's a particular input here. You can see the arrow pointing in. So this would be a voltage input in this case, or ground input to the ZR to tell it something, whether that's a condition or whatnot. And then in our case, it looks like an input here, and it's pin D01, pointed out right here. But when looking at the wiring diagram, I noticed that something did not seem right because of the diode here and down here, if I had 24 volts coming from the flasher circuit and it went to the diode, it could not go past into the ZR. So something didn't seem correct here when I was looking at this wiring diagram, which is an official diagram. And when I looked a little bit deeper on another similar diagram for the page, I had noticed that in fact it should have looked like this. So the power comes in, it goes into here, and it goes to D2 and powers up the ZR if you press the hazard switch. And then that power also goes through DB1 down here and then out the bottom to turn on the master 24 volt relay for the whole bus. So it's important when you're looking at the wiring diagram, there are mistakes sometimes. They're not very frequent. But if something does not look right, go back to the portal and make sure you have the most up-to-date wiring diagram and you're not working with too old of a diagram. Okay, so there was a lot of small descriptions on all the components on the previous page we just looked at. When looking at the wiring diagrams for the vehicle, you'll notice that there'll be a page before every one of the actual schematics that you see. In that page, they will highlight the most important components on the page. So in our case, we saw plus 30 for the main master switch on power supply. So anytime you see plus 30 on the page, that has 24 volts when the master switch is on. We also saw B+, which is down here, says direct to battery, which means it does not need, nothing needs to be turned on in order for there to be power on a B+ circuit. We also have the master switch SO68, and then we have the SO80, which is the key switch, which are actually both one and the same on our particular diagram. And then there's additional switches labeled out here, SO77 for the start switch, D for a diode. And then looking a little bit further, we also have the DMUX, which is the dashboard green screen area in the center of the dashboard, RL511.5 or 4, so battery guard feature. This shows RL511.4 for the battery guard. Our wiring diagram showed it as RL511.5. So once again, another small typo that can throw you off if you're not understanding how the circuit works in general as you go through it. ZR is the main computer for the body. DB stands for diode block. Node 3, body module controlled by the ZR. And then EKV and IB is the junction box locations. So in the wiring diagram, there are lines between certain sections of the diagram, which we'll look at next. And they show where there's plugs at the junction box, where all those components are housed. And that's where we can check the circuits and see where we have 24 volts or ground. So one of the other common mistakes that happens is that you look at a wiring diagram or you're talking to somebody to troubleshoot and they say something like, check at the DMUX. And you may not even know what the DMUX is. And that's very possible. So it's really important that when you're going through the coach, or you're working on a coach, or you're working on troubleshooting something, that you look in the maintenance manual and you get yourself familiar with the components. So for example, the DMUX, as we discussed before, this is the back side of the dashboard, and the DMUX is this center section, the silver part. And these are the plugs that go into the DMUX. All the plugs are labeled. so you can find the plug and the pin numbers accordingly to how they show up on the wiring diagram. But if you didn't know what a demux was, you would have a difficult time trying to troubleshoot it. So it's very important that you understand what those components are on the wiring diagram as they're described. ZR is the computer that controls all the multiplexing on the bus. It makes those nodes function correctly, and it also communicates between the demux. It's communication between the ZR and the demux. So when I push buttons on the dash, the information goes to the ZR via the demux. The multiplex node, all the nodes are the same on a Von Hool coach, and they all operate off of 24 volts. So it's either 24 volts or 0 volts as an output when something is being controlled. So breakers and fuses. With the Von Hool wiring diagrams, breakers and fuses, the terms are used pretty interchangeably. So most of the components are operated with circuit breakers that have a center button right here in the center that will pop out to show you that the breaker's been tripped. And if you manually push this switch here at the top, it'll actually trip it for you. So if you wanted to turn a circuit off, you can turn it off by just tripping the switch. The diodes, individual diodes, you can see here, they're gonna be two wires. They go into a special holder inside the electrical box. And according to the wiring diagram, this is how the diode is installed based on the direction in the wiring diagram. So the line on the diode, it should match the line, the white line that's on the diode itself. So when you're checking, you can check those with a meter. There's a special setting in your multimeter to check diodes. So if you need to check them with a diode function of your multimeter. The diode block is essentially, I think, about 9 of these little diodes inside this one relay-based style housing block. So there's a master switch. It's important to realize what the master switch looks like and where it's located on the coach when you go to operate it and do the testing. Sometimes you may have the wrong switch, or maybe the switch is not labeled at all, and the reason why the bus doesn't turn on is because you've accidentally pressed the wrong switch. And then you have a relay. In this particular case, the relay looks just like the diode block, except there's a lot less pins. There's only 2 pins for the coil that control the relay, and then there are 3 pins on the relay itself. One is a common, and then you have a normally closed and a normally open contact. But it's important to understand what relay you are looking for, because there are larger relays used for things to control, like all the air conditioning fans. So when you see a relay on the wiring diagram page, you should always go to the beginning of the diagram and make sure that you understand which type of relay it is, if it's the small 15-20 amp relay, or if it's a 30 amp relay, or a very large 50 amp relay. So it's very important when troubleshooting that you understand what every one of these components looks like, so that you make sure you're checking and troubleshooting the right spots. Alright, so now we have this wiring diagram. We've gone through and we've identified what all of these components are. We know what the relays look like, we know where the ZR is located, we know where the demux is located, the switches, the breakers. If you don't know which compartment they're located in, as I said earlier, these little dotted lines over here, they separate what stuff is located in which compartment. So if we follow this dotted line all the way over to the right off the page to the end, you'll see a little IB to the right corner of it. And the IB stands for instrument board. And what that means is that everything that is up here is off the instrument board, and everything between here and here is inside the instrument panel, which makes sense because the demux is going to be in the instrument panel. This B plus over here, this circuit breaker, is not in the instrument panel area. There'll usually be another indication to say that it's most likely in the front electrical box. That's where it is on almost all the Von Hools. And then afterwards, if we go down here, we'll see if we follow this line all the way out to the right, you'll see that it'll show that this stuff is in the first electrical box, which is also common in most Von Hools. That houses the ZR, it houses the node 3, the diode blocks, and the relay 511.15. So with this information in hand, what we need to do is we need to start at the top of the circuit, which is going to be the B plus up here. And from the top of the circuit, we're going to follow through. We see it goes through plug 113, pin number 12, which you can see right here. And then we can check right at that plug, pin 113, pin 12, and we can check for 24 volts. Or we can first check right at the breaker itself. If we don't have 24 volts at the breaker, there's no point in going further down this circuit and checking anything else. We need to first figure out why we don't have voltage there. If we do, we continue on, we'll see there should be 24 volts at pin 4 of SO68, which is in the dash, And if we have our switch turned to the first, or not switch activated to the middle position, which is the essentially the ignition. Let's see, would not be the ignition position. It would be like the accessory position on a car. So if we have it to the middle position, we should have 24 volts on pin 6. So we would check the back of switch for pin 4. It's a blue and orange wire. That's what the B and O stand for. And then coming out the other end, a blue and white wire. So it has blue with a white tracer. We should have 24 volts. And it goes all the way down to plug 111.6. Looks like 0.6 here. Or could be 8. And then it would go through this connector. So we can check here also for 24 volts. We should have 24 volts all the way through. From there, we can go to relay 511.5. We can pull this relay out, and in our case, we would be able to check and make sure we have 24 volts at pin 30. And then if we had the relay installed and we checked the back of the relay base, we would check and see that we have voltage at pin 87A, which is this side right over here. So that's the relay is not normally activated. Just as a note of what this does, this relay is simply designed to activate if the battery voltage gets too low. And essentially what that does is it will trip this way and it will turn off the master switch to the rest of the circuit. So it acts as if you went inside and turned off the master switch. From here, the voltage goes down to node 3, pin D2. These are 24 volts. And then we also have voltage goes to diode block over here in pin 3 and out pin 5 and off to another part of the circuit, which we won't worry about right now, because for our checks we want to make sure that we have 24 volts at node 3, pin D2. This is common on all Von Hool coaches that use these multiplex nodes for many years. If you do not have power there, 24 volt voltage there, the coach will not turn on completely. And typically what happens is the dashboard says system fail, and that's about it. So the dashboard comes on, but the rest of the bus does not. And the reason why most of the time is either bad circuit to pin D2 and you don't have 24 volts with the switch on, or there's maybe something wrong with node 3. From here, we would check the circuit. We make sure at the DMUX that we have power at plug D, pin 01, so it should be 24 volts there. So if so far we've gone through the circuit, we would be checking for 24 volts at these locations. Then we trace it through some more, and it goes back up to that master switch we saw earlier on pin number 7. If we turn the master switch all the way to the on position, no longer the accessory position, we would have voltage at pin 7 and at pin 3 if the switch is good. From there, the voltage goes down through this diode, and it goes into the DMUX on plug D, pin 19. Another point to note, these diodes are notorious for failing, and they fail intermittently. So we may have 24 volts coming into one end of the diode, and it may not come out the other end, and you won't get any power on the dash. If you sometimes grab these diodes and you flex them a little bit, they're located right behind the dashboard. They're black plastic diodes. You can usually get the system to work and then not work. That's a good indication that the diode is faulty and are pretty easy to replace. They just unplug and a new one gets plugged in. So also here on the right hand side of the page, this particular part of the circuit where it starts up here, this comes from the hazard switch. So when you turn the hazard switch on, 24 volts comes down this orange and green wire, goes into here and powers up the ZR directly on this input. This is an auxiliary way of turning on the ZR. It also goes through the diode block and it continues on and goes down to the master relay so that the lights work. The whole function of this side of the circuit is strictly for hazard lights, to make sure that enough power is turned on in the bus to run the hazard lights. Something else we can learn when looking at this diagram for starting up the coach is that the ZR does not need to see voltage for the normal ignition and master power circuit. What needs to see voltage is node 3 D2, and that input is the most important input to get the program running and everything to turn on. So I can't emphasize that enough. Node 3 D2 is the most important input to get everything powered up. The ZR is technically always powered, and once it sees communication and sees things happening from node 3, it will turn on everything else and get the program running on its own. Now some final notes. To use your knowledge of where there should be 24 volts or 0 volts to test at each component on the vehicle. That's very important. Go through the diagram first, make some notes of where you should test and what kind of voltage you should see there. Start at one end of the circuit and work through to the other end. Follow it all the way through from the power source all the way through to either the multiplex node or the demux for testing for circuits. There may be things happening after it goes into one of those modules that may require more advanced troubleshooting skills. However, most of the time the problem is just a poor connection to the node, and if you do have good power going into the nodes and it's still not functioning correctly, you may just have a faulty node. In that case, you can swap one node with another one that doesn't use that input or output, and that will tell you if the node is good or not. Always test your meter on a good battery source to make sure that it works correctly. I've had many times where you will be using a multimeter and you'll get readings and they don't look correct or they're not correct, and you assume that the problem is with the vehicle, and the problem really is with the meter. So it's really important that you test your meter, you make sure it works, go to the battery, confirm on the battery it's actually functioning correctly, that you didn't blow a fuse out or something in the meter. Do not rely on test lights for checking circuits. 12 volts can light up a test light, but it's not enough to activate the input on a node. And it can also throw you off and make you think there's voltage present there that's able to make the system function when there isn't. Test lights can also fool a node into thinking the input's been grounded. So if I put an old-fashioned test light on an input to a node that's supposed to look for a switch, the light may light up, or it'll think the circuit's grounded and then throw off your readings. So it's really important that you always use a multimeter and get voltage readings. Always make sure you have the most up-to-date wiring diagram before working on an electrical issue. A couple of the examples were pretty obvious in this wiring diagram. That is an official one. It's probably the same type that'd be on a bench somewhere in somebody's toolbox. It's just been floating around. It's not the most recent one from the portal. And so in that case, there were mistakes that were present there that could have thrown you off if you were only using that and didn't think to question what you have at hand. So don't always assume that the diagram is exactly matching what you're looking at. And if you have questions, make sure to call customer care for your particular company and get some additional help. This information's out there, it's available, but it all starts with making up a checklist, look at where you have to check and what you need to see, and then take that information back. When troubleshooting, it's a lot easier to say, hey, I have 24 volts at node 2 D5, if that was what you're searching for, and that helps the person on the other end of the line help you troubleshoot even further, because now they know where you're looking and what you're looking for and what you didn't get. And if you like this video, please give it a thumbs up. This is my first YouTube video for the world. I'd like to make more of them if it's helpful for everybody. So any input you can provide to me is beneficial, and I appreciate your time.